Differentiability and continuity. So we're going to mix these two topics together. Differentiability, though. So is a function always differentiable? And that question, the answer to it is no. And how would that be? Well, you remember how a derivative, we went back to the definition of it. I know you're going to hate this, but if we went back to that formal definition of it, the limit is h goes to 0 of f of x plus h minus f of x over h. Now, what I'm trying to say here, the main part is it's a limit. And does a limit always exist? No. So what would cause this to fail? There's some things that would cause this to fail. So let's talk about those after I draw a straight line. Boom, perfect. All right, so one thing is called a cusp or a corner. This is kind of a mix between the two. So what's going on at this particular point, so it is continuous here, but what's going on is that the slope from the left and the slope from the right are different. Think about that. The slope from the left, this is like what? Let's just say 1, m equals 1. We'll put m with a little negative for m from the left. And then m from the right is like, it looks like maybe like negative 10 or something. It's pretty steep there, right? So the slope is different from the left and then from the right. So that could cause, or not that could, that causes it not to be differentiable there. So there's an issue with that. The next thing is, what if it's not continuous? If it's not continuous, then we can't differentiate. And this one is important because if they tell you, if they say in a problem, let's say they just start it with f of x is continuous, then that's going to imply that it is, or not continuous. Let's just say that they say f of x is differentiable. That's going to imply that it is also continuous. Why? Because in order to claim it's differentiable, it means that there's no discontinuities. Because if there's a discontinuity in there, it wouldn't be differentiable. So by saying f of x is differentiable, is also saying that f is continuous. So they won't state them both usually in the problem. They'll just tell you f of x is differentiable. And they won't need to tell you it's continuous because you should already know that. And then what about the cusp and corner? Well, this is not differentiable, but it is continuous. So you don't have to, if you say the function's continuous, does not for sure mean it's differentiable. Remember, it's continuous at that spot, but not differentiable. So continuity does not imply differentiability, but differentiability does imply continuity. Really important. Think about that one. That is something you need to know for AP and just calculus in general. There's also the vertical tangent. Why the vertical tangent? Because m is undefined. M is undefined at a vertical tangent, so if slope is undefined, then obviously it's not differentiable in the first place. So these are the three things we're looking for. We're looking for the corners and the cusp. It is continuous there. I do want to make sure you do know this is continuous, but not differentiable. If there's a discontinuity, automatically differentiability is out. You need to have continuity for differentiability. And then vertical tangents, that slope's undefined. So it is continuous here in this graph. If this red line was removed, you'd see it's continuous, just the function's undefined. Now they will try to trick you in the assignment. They'll try to throw these kind of things at you and you're thinking, oh, whoa, we got a horizontal tangent. No, horizontal tangent's fine. Slope is 0. It's the vertical tangents that don't work. So beware of that. So let's look at this assignment. Find all values in which it's not differentiable. So I'm looking right here at negative 3, discontinuity. Boom, not differentiable. What about at positive 3, vertical tangent? Boom, not differentiable. 0's fine. Everything's good there. 6, everything's good there. The slope is 0, but it doesn't mean that it's not differentiable. Right here, where's it not differentiable? Well, we have in discontinuity, big time discontinuity at negative 3. Discontinuity at 1. And look at this at 3. Even though it's differentiable, it is a cusp / corner. Kind of a mix of the two. A cusp is usually, if I could draw it, that would be a cusp, and a corner is more the straight, if you want to know the technical difference. And last, negative 2, it's not continuous, so it's not differentiable. 0 is fine. I think I threw this in there so you can see that. That is fine, but what is not fine is at 4, that's the vertical tangent there. And I think they'll tell you that there's a vertical tangent just because sometimes it might look like there's a vertical tangent, but there isn't. So usually it'll be specified in the problem. So there is a vertical tangent at 4. There's discontinuity at -2. And then also look at 2. That is a corner/cusp. So that one is also not differentiable. And that's the idea. We're really just looking for these 3 things. And I think the big thing to take away from this video is that if it's differentiable, if I tell you that f is differentiable, that means it's also continuous. Because if there's a discontinuity, differentiability is ruled out. And also, you can have continuity and it not be differentiable. So let me just write that one more time. Differentiability implies continuity. Continuity does not imply differentiability. You can have something that's continuous, like a corner or a cusp, and it not be differentiable.